Hi class, in this video go over chapter 12, the topic on environmental protection and also negative externality. So this is a two-chapter series. So chapter 12 go over the negative externality, and then chapter 13, next chapter, going to go over the positive externality. All right, so so we're going to study about pollution and then also the policies and strategies on how to manage the pollution and why does pollution even exist in the economy. All right, so since 1970s, U.S. has been introducing a lot of anti-pollution policies. So many of them are dealing with, how companies, especially industries, polluting the air, and also think about the smaller policies such as um, the the pollution control on each of our individual gasoline cars. So those policies we introduced in 1970s try to reduce the pollutions, not just air pollution, but also think about the water pollution, noise pollution. So those Pollution Act are in place to fix what was wrong with our environment. But the those acts are not free, right? Because for every single policy we put in place, try to control pollution, that we're actually putting a restriction on economic productions. Because most of the pollution coming as a result of economic productions. All right, so a couple definitions. So know what's externality. So externality is like this spillover effect. So it's the benefit or losses, impacted by the third party who are outside of our traditional supply-demand transactions. So for this chapter, we're going to study the negative externality. So this is where the third party outside of supply-demand transaction suffers from market transaction by others. So some innocent bystander who is not the buyer, who is not the seller, but they're still paying a cost of this supply-demand transaction. And then next chapter, chapter 13, we're going to study the positive externality that will be the benefit experienced by the third party who are outside of our supply-demand transactions. Now, pollution is a negative externality because for pollutions, the victim for pollutions are often not part of our supply demand transaction. So think about, let's say, gasoline, right? So if you go to a gas station, purchase gasoline, then you're the demand for gasoline, and then the oil company, the gas station, there's a supply for gasoline. But what if you have a neighbor who doesn't own a car? And he only goes everywhere on either by foot or take a bicycle, then the more you drive, the more gasoline your car consumes, the worse the air quality is, right? So that bystander, your neighbor, who is not part of our supply demand diagram here, but this person is also paying a cost of pollution. So imagine this person need to purchase additional air purifier for the house, or he might have a medical bill due to the pollution impact, right? So those would be the additional cost, additional external cost that's burdened by the third party who are outside of supply demand diagram, and this cost will increase as the more and more of the demand and supply increase for gasoline. And also note the social cost. So social cost is the total cost that includes both the cost that's burdened on the supplier and also the cost that's burdened on the third party. So think about our gasoline consumption again. The social cost will be how much it costs the company to produce the gasoline, and this external cost on your neighbor who need to buy, who has a higher medical bill, buy more air purifiers. So social cost is cost of everybody, not just the production cost, but also the external cost from pollutions. Now, when you have a social cost situation, more than likely that, again, due to pollution, that your social cost will be more than your private cost. So how much the real cost is for production is actually more than how much the production cost that's burdened by individual companies. So for example, here, let's say for a refrigerator, with no pollution control, then company can produce refrigerator, and each refrigerator, the cost will be $6.50. But what if there's also pollution cost? Let's suppose the pollution cost is $50 per unit. So the true cost, the social cost, will be actually about $700, right? So the social cost is more than our private cost, and that's because we have a negative externality here, right? So additional cost is put on the market, and therefore we should produce less refrigerators because the the total cost is actually higher. But if you have the market, if you have consumers who are only paying the private cost, then we're gonna overconsume our refrigerators, right? Because if you're only paying what the production cost is, that's pretty cheap. You're gonna buy more refrigerators. But what if we force the consumers to pay for the entire cost? That will be the production cost and the pollution cost. So now when the price becomes 700, our consumption is only down to 40,000, right? So this quantity here, where the social cost curve is, that's also known as the socially desired output. So the socially desired output will be less than your private desired output whenever there's a pollution involved, right? So if the market is left to the buyer and sellers, we're gonna overconsume than what the socially desired output amount is. All right, so also know what's a market failure. So market failure is whenever the market left by itself cannot achieve the socially desired output. So we cannot address all the social benefit, all the social cost, then we're either overly consumed with the pollution or undersupplied with any type of positive benefit. And those are all called a market failure. So in the previous example, if the market is left by itself, we can not reach the socially desired outcome, actually produce and consume more refrigerators, and that will be an example of a market failure. So there are different ways to fix this market failure. The first one is called a command and control regulation. So the command and control regulation, that's putting a hard limit on how much the company can pollute. So imagine our government says, we're going to set up a limit on the production, on the pollution quantity for each company. So let's say for each oil company can only produce, I don't know, maybe 20 tons of carbon dioxide, right? So that will be a command and control regulation. So putting a hard limit on how much the pollution is. Now this is it's effective because you can limit how much the pollution is, but it's not efficient because there's a couple reasons. So for one, this command control policy does not offer any incentive for company to improve on their environmental protection standards. So imagine, let's suppose we have an oil company, again, their production limit is 20 tons of carbon dioxide, and then the company now have a new way to reduce the pollution. Well, they don't want to, they don't have to, they don't need to, right? Because there's no incentive for it. Because as long as you stay at below 20 tons, you're doing fine. So company have no incentive to go below that or to go even further down below. And next is not flexible. So this command control policy here is setting the same standard for every production in the economy, but some production might have more pollution than others. And lastly, that this is also subject to any type of political process. So anytime you might have a loophole existing for companies, you might have exception for companies, right? So it doesn't really apply to everybody. There's a fine print involved. All right, so the other type of pollution measurement is called a pollution charge. So a tax imposed on the quantity of pollution company can emit. Now this will be more flexible. So this tax will just make the production more expensive. So if company want to produce more because they have to, we're gonna pay a tax on it. But if you're producing less, then if you don't have to produce this good, then you don't need to pay the tax anymore. So imagine we have, let's say the oil company, right? So the oil company have a choice. They can either produce more gasoline or produce more, I don't know, what's the useless chemical? Let's suppose they have a useless chemical that nobody ever need, right? So if given this choice, that will put a charge on the different type of production, then company would try to use this opportunity wisely and then only produce the good that's really needed by the economy to justify the higher tax they're going to pay for the pollution. And then for the good that they don't need, for the good that nobody purchases, then they don't have to produce this good anymore. Okay. So imagine we impose a charge of $1,000 for pollution for this 30 pounds of production company gonna have. And then the cost to correct this, to fix the pollution, costs $900. Now, if you had a command and control policy with no incentive, then company just, hey, let me just pollute it because this is my limit and I can reach the limit with no extra penalty, then there's no incentive for me to change. But now we put an extra charge on it, says, hey, if you're gonna pollute, we're gonna charge you money for it. And then this charge is more than how much it costs to fix the problem. And what do company do? They will pay the money to fix it because it's actually cheaper to fix it than pay the charge on it. So the this pollution charge policy approach have a incentive for company to reduce the level of pollution. There's another one, it's called a marketable permit program. It's also known as cap and trade program. It's very popular in Europe. So government actually set up a cap of the pollution and then allow the companies to trade any excess pollution permit they might have. So for example, let's suppose we say, hey, each company have a allowable pollution of let's say 1,000 ton. Um, and then if one company is able to reduce the pollution, they might say only pollute about 900. So that excess 100 tons of pollution, they can sell the permit to another company who really need it, right? So this marketable permit program really give companies more incentive to stay under the pollution limit, and then because they can get a profit out of it. All right, so no, also known as a property right. So the most difficult issue with pollution or with any type of environmental concern is we don't have a very clear set point of property right. So who owns the property right? Who has the right to a clean air, to a clean environment? Now, once you have a very defined property right, then the way to fix the pollution will be very, very straightforward. But the problem is we don't have a very defined set of property right for pollutions. All right, so the benefit of a cleaner environment. So for one, people are healthy and live longer. So if you look at the life expectancy from between many developing countries who are very, very polluted, so countries like India, China, Pakistan, versus some of the more wealthy country who has much cleaner environment, then you're going to see a big difference between the level of the people's health condition and also how long do people live. Also, certain type of industry depends on clean environment. So think about water recreation. Think about the clean beach, farming, fishing, right? So those depends on a clean industry. So if you are, let's suppose you're a country, you have a choice. You can either choose to pollute to keep your, let's say, a coal mine, or you can have a clean air, but in return you also get clean beach, more farming, more fishing. So which one do you choose? Um, and then third, property value might be higher too. So if you're living in a very clean environment, you're gonna see a higher property value. So for any owner of the property, they also be better off. And lastly, the people just enjoy clean air. People always want to live where the clean air is. And then for let's say for the example of Houston, where I am now, if you look at the property value in the Houston area, the west side is tend to be more expensive. The east side is a little cheaper, and that's because that's where the refineries are, right? Because over there you have a not a very clean environment. We can also use the marginal analysis to study the benefit and cost of pollution. So according to what we learned before, marginal cost of anything is increasing, and the marginal benefit of anything is decreasing, right? So if you try to control and fix the pollution problem, we're gonna really compare to see what is the marginal cost of fixing the pollution versus what's the marginal benefit of having clean airs. Now imagine if right now the economy is currently at QA. So at QA have very high pollution, but also happens at QA with high pollution, our marginal benefit for clean air is very high. Our marginal cost is very low. So if you're at QA, then the entire society have incentive to have more clean air, to put more restrictions on pollution because our marginal benefit is way more than marginal cost. But if you keep doing this, so the more and more environmental protection you have, the lower the marginal benefit, the higher the marginal cost, right? Because for many countries who are first starting having environmental protections, there are some low-hanging fruit, some easy target, some easy approaches government can choose, right? So, for example, maybe reducing the consumption of, I don't know, plastic bags, or maybe phasing out many of the older cars who are very, very dirty, right? So those will be easy thing to do. But once you already introduce those measurements and you want to fix your environment even more, then you're going to make some hard choices. Now, for the hard choices, they're going to come with lower marginal benefit and a higher marginal cost. So for this example here, if the government of the country keep improving their airs, so keep introducing more environmental protection, then we eventually going to reach this point QB. So at QB, the market is at equilibrium. So at this point, the marginal benefit of environmental protection is equal to our marginal cost of environmental protection. Now again, everybody want to have clean air. Everybody want to have a clean environment. Why not just go over that? Why not just having, let's say, absolute zero pollution, right? So a lot more environmental protection. Now going beyond that point, beyond the QB, so if you go to QC, our marginal cost will be very, very high for environmental protection, but the marginal benefit is very, very low. So imagine our government says every car on the road must be an electrical vehicle. And then let's say government also decided that every meat product you consume had to be organic and then also pollution free. Now that's a too much cost for consumers, right? So even though we are getting more better environmental protection, but it's going to be at a very high cost that people just can't do it, right? So there's a optimal amount between your protections according to our marginal benefit, marginal cost. Also know that environmental issues tend to be international, that pollutions tend to be spilled over to other countries. So because your pollution doesn't care about borders, right? So there are news from Korea and Japan. Sometimes they blame their air quality because of the pollution in China. There are truths to it because those dirty air from one country tend to blow to other countries. So it's difficult for one country to by themselves to fix the global warming problem or the problem of pollution. So we need a couple definitions. So we need biodiversity, right? So for biodiversity, that really is the amount of diverse animal and plants we have available in the ecosystem, and those are important for genetic reasons. But for this biodiversity, we need every country to be part of it. So one country cannot achieve biodiversity by themselves. I mean, it's impossible to have penguins in the North Pole. No, this is a joke, right? Because penguins are in the South Pole. All right. Also known as international externality. So this is whenever you have this especially pollution that cross borders that one country by itself cannot resolve. So historically, most of the pollutions in the world are coming from developed countries, so high-income countries. So think about the countries in Europe who first started, the Industrial Revolution back in the 1800s. That's where most of the pollution came from in the developed countries, and it's still happening today. So many of the consumption of gasoline by cars, by factories in the developed countries are still a big source of global warming. Now, however, might be a very bad example that many of the developing countries are catching up in the sense of pollution. So some of the most polluted country in the world today is actually a country like China, India, because that's where the factory is right now, right? So for all the stuff we buy from China, all the stuff we import from India, that's also contributing to the pollution in those countries. And that's why many countries get together, we sign this Paris Climate Agreement to try to put a cap on how much the total emission of CO2 in the environment, and then when we put the global cap, we assign a number to each country, a goal for each country to stay under of. Now, however, for this Paris Climate Agreement, it's really difficult for government to impose those limits on their own economy because, again, of the command control regulation around the world, that it's just not efficient. And that's why it might be more efficient to have a decentralized market approach. So to have more cap and trade, imagine across borders, so more international cap and trade allow companies to have an incentive to stay under this limit and then trade or sell the excess capacity they might have of pollution. Now, lastly, we can also use our PPF, the production path frontier, to see what is the impact for pollution is. So remember, on the PPF, any country want to be efficient. We don't want to be inefficient. So for the PPF, anywhere outside the PPF is impossible. Inside is inefficient. And so remember, anywhere on the line here is efficient. So P, Q, R, S, T are all efficient. And on the vertical axis, we have the economic output. And on the horizontal axis, we have the environmental protection. So we're assuming that there's a trade-off between economic output and environmental protection. So the more protection you have for the environment, the lower the economic output. But the higher the economic output, the lower the environmental protection, right? So we want to be as efficient as possible, but on this efficient point, so between P, Q, R, S, T, what is best for each individual country is up to each individual country. Now, as the entire globe, we might want everybody to be at either point T or point S, right? So a lot of protection for the environment. But as individual country, they might want to be over here at point P, which allow for more economic output. But nobody want to be at point M because point M that's inefficient. Okay. All right, guys. So that's it for this chapter. Any question, let me know, and I will see you for next chapter. All right. Bye bye. On the vertical axis.